We're still in lesson 1.2. We finished the first part where we graphed a function that was in vertex form. Now we're going to graph a function that is given to us in intercept form. It's important to get copied in your notes what intercept form looks like. It's y equals a times the difference of x and p times the difference of y and q. Now, similarly, that when we had the vertex form, there were certain things that we could figure out from that format. With with intercept form, there are certain things that we can figure out. Or the intercept form has characteristics. For instance, we can tell our x-intercepts, if there are two x-intercepts, for our parabola just by looking at the p-value and just by looking at the q-value. Now, you got to think with me. It's x plus 3. Our form says x minus p. How could we turn that into x minus? We would have to say x minus a negative 3. So our p-value is really negative 3. That is our p-value. From that, we can create the ordered pair of where this parabola crosses the x-axis. Negative 3, 0. That is where the parabola crosses the x-axis at one point. This particular parabola may have two x-intercepts. And in fact, it does. It has a q-value. Now, this is already in x minus 1 form. So our q value is positive 1. I'll use blue ink for that. So right now, we have two x-intercepts. We also know the axis of symmetry. The axis of symmetry is simply the sum of p and q divided by 2. We're going to add the p and the q value together, whatever that is, and divide it by 2. I'll use red ink for that. Now, our p value is what? Negative 3. We're going to add that to positive 1 and divide by 2. Negative 3 plus 1 is negative 2. Negative 2 divided by 2 is negative 1. That is our axis of symmetry. All right? Now, from that point, we can actually use it and create our vertex. Because when you think about the parabola, let's see, it's positive 2. Looks like it's going to be going up to me. And then that axis of symmetry will be running through the center of that parabola. All right, so let's do a quick review. We've identified our p and our q, which are our x-intercepts. We've also identified the axis of symmetry. The last thing is, as I've already kind of jumped the gun, is we can look at our a value, 2, and we know that this is going to be an upward pointing parabola. Upward pointing parabola. All right? Now, let's come over here and let's use red ink. I like to use red for my graphs for some reason. And let's draw us a nice, quick graph. Okay? If we want to put arrowheads on there, it only takes a second. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, in future videos, I might already have that on there. But it's important to know that drawing a quick graph is not a big deal. Now, let's go ahead and put some points on here. We know the green ordered pair and the blue ordered pair, those are where the x-intercepts are. So we've got 1 at x equals negative 3, and we've got 1, we'll use blue ink, keep it consistent, right here. We even know that our axis of symmetry is going through the point -1. So where's the -1 on the x-axis? It's right here. So I'm going to do the best of my ability to create a dotted line. Now my y-axis is a little curve, so I'm going to play the game. And there's the axis of symmetry. The question is where is my vertex on that axis of symmetry? Is it way down here? Is it here? Is it here? Is it here? Could it be up here? No, it could not be up here, because if it were up here, that would create a downward parabola, and we know from our format, 2, positive 2, is greater than 0, so it's got to be an upward pointing. So it's going to be less than, it's going to be a negative y value. The key is we can find the vertex. And how the heck are we going to find the vertex? Well, we're going to use the x value of -1. Why -1? Because -1 was our axis of symmetry, and we know that our vertex falls somewhere on the axis of symmetry. So we can go and we can say y equals twice x plus 3 times x minus 1. Wherever I see an x, I can plug in a -1. Do the math. We're going to use our calculator. Do the math. 2 times 2 is 4. 4 times 2 is -8. So our y value is -8. If our x is -1 and our y is -8, then our vertex, and I'll just use black ink, our vertex is -1, -8. Bam. From those 3 points, I can now draw my parabola. And it looks something like that right there. Quick review. Intercept form, characteristics. P and Q are my x-intercepts. Axis of symmetry is going to be the sum of P and Q divided by 2. That's how I knew to draw my dotted line. Where the heck does the vertex fall? We know it's got to be below, because it's got to be upward pointing. Because the A value told us that. When I plug in x equals -1, it produced -8 for my y. Bam, I have my vertex. So what is this right here? That is the vertex. Bam. These two are my x-intercepts. That is how you graph a function that starts out being in intercept form.